Okay, so for this unit, we're going to be talking about measurement. And measurement is actually, the origins of measurement come from communication. And basically what it is, let's say that there's two of us that are trying to build the same thing. And we want it to be identical. We want them to be exactly the same. Well, if we're in the same room together, it's not so bad to try to do that. We can just, walk over and look at what the other person's building and compare sizes or whatever. But if one of us is down the hall or even across town, that's not possible. It's kind of difficult to compare sizes. So in order to make that work, we have to have some way that over a distance we can describe that size of that object. Now, I suppose you could cut a piece of rope or a stick or something to that size and send it down there and say, okay, it's this big. But it'd be really nice if you could record it, draw a picture or whatever and be able to label, this piece is this size and that piece and so on. So one of the things they were able to do, or one of the things they came up with, is just comparing it to other objects. Take this sheet of paper here. They might take a pen and say, okay, it's 1, 2, it's about 2.5 pens long. So then I'll send a message to you saying, hey, you need to cut a piece about 2.5 pens long.
If you don't have
so
the
that
same pen.
you take your pen and you go, okay, there's 1, 2, well, 2.5 for you is about that long. So for that to be an effective measurement tool, two things have to happen. One, the other person has to have one of those objects. And two, the one they have has to be about the same size. So obviously a pen wouldn't work. They tried things like stones or sticks or whatever. Well, sticks have a wide variety of sizes, so that didn't work real well either. So what they settled on were some common things that pretty much everybody had. For example, if we're looking at length, which is kind of the example I used in the picture there, and we're going to start out talking about standard units, sometimes called English standard units or British standard units. We don't call them that anymore. We just call them standard because it's been about 15 years since England switched over to the metric system, which we are now officially the only industrialized nation in the world that's not using the metric system, which we'll talk about that in a little bit. But anyway, for length in the standard system, what they decided to use, because pretty much everybody had it, one of the first things they used was the inch. The inch came from the end of your thumb to the point of that first knuckle. That was an inch. So you'd take your piece of paper and you'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm getting just under 11. So my thumb's actually slightly bigger than an inch, but there was some variation, but it was fairly close from one person to another. Now, obviously there were things bigger than an inch. What do we have in our standard system that's bigger than an inch that we use? What's the next unit up? A foot is what we commonly look at for the next unit up. How many inches are in a foot? There's 12 inches in a foot. Now, when this measurement originally started, there wasn't 12 inches in a foot. In fact, there was no relationship between feet and inches. They were used for totally separate things. Inches were used for measuring smaller things. Feet were used for measuring larger things. They didn't convert between them at all. There was no conversion between them. Now, there was some weaknesses to measuring with a foot. The one weakness might be, let's say I want to measure the height of this wall behind me. Can I do that by measuring in feet? Well, now we would measure it in feet. But remember, originally you had to actually put your foot there and compare. I could get up to maybe about here with some serious stretching, but I'm not making it all the way to the top. Unless I maybe chop it off at the ankle or something. But a foot could only really measure things that were along the ground because that's where feet usually are. If I wanted to measure something vertical, like a wall, they used hands. The hand was the width across your hand at the base of the fingers. That was typically about 4 inches. Now again, that wasn't a conversion. Now it's considered to be 4 inches. Things that were vertical like that were measured with hands because you couldn't get your foot there. To this day, livestock, horses, sheep, cows are still measured in hands. There were some changes that were made, and actually there were other units that were, like for things that were horizontal but up off the ground, like in construction, they used a unit called the cubit. Anybody ever heard of a cubit? Cubit goes from the tip of your longest finger to the point of your elbow. A cubit was about, now again, we've grown taller through the years, so I've measured mine and it's like 18.5 inches. But the typical cubit back then was about 16 inches. Anybody think of anything in construction that's measured at 16 inches? Pretty much everything. Yeah, your joist spacing is 16 inches, your stud spacing 16 inches. In the old beam and rafter construction, rafters were 16 inches. I mean, that's how everything was laid out in construction. You just put your arm down there, and that was a cubit, and that's how you spaced everything. That was the unit for construction. Somewhere around the 500s, 80, King Edward declared that his hand and his thumb and his foot and his cubit, his arm, were going to be the official units of measurement for everybody in his kingdom. So they came in and they took pieces of wood next to his thumb and they cut them, and to his foot and they cut them, and then they passed those out, duplicated them, and passed them out for everybody to use. Now this was strictly an egotistical move by King Edward, but it turned out to have some great advances in measurement. One, now that I have a chunk of wood for a foot, I don't have to get my foot up to the top of the wall. So it's a lot quicker to measure it with a foot than it is to stack your hands on top of each other because the foot was larger. So units like the hand and the cubit were no longer as necessary anymore. The second thing it did, if I'm going to measure an object, I would take that piece of wood or my thumb for an inch or whatever, and I'd put it on there, and then I would slide it over. So I'd go, there's one, then I'd slide it over. Oops. Not very well, apparently. Get in there. There we go. I'd slide it over, there's 2. Slide it over again, 3. Well, every time I slide that piece over, there's a chance that I don't get the end of it or the beginning of it where the last one ended, right? So there's a little bit of an error every time I slide it. So what they discovered is, rather than sliding it over every time, we can take a stick and we can mark it. I'm just going to mark on this stick. There's one, and then I'm going to slide it over and mark the end of it and keep sliding it. And that's where the ruler came from. In fact, at some point, then they started numbering it. So rather than having to count the marks on that stick, they were already numbered. And then if they wanted to measure smaller things, they started, we can cut them in half. And we can distinguish.
That his thumb was actually 12?
No.
Oh.
His foot was not 12 of his thumbs. Okay. It was about 200 years later somebody decided, hey, if you measure something in feet and I measure something in inches, it'd be nice to be able to compare to see how close they are to the same. So then they adjusted the foot and the inch so that 12 of them fit into the foot. And all the other ones they adjusted so they fit in, so that there was a comparison. There were some that didn't adjust real well, so they had to leave them with some awkward conversions. But like I said, King Edward's act of egotism served a great advancements in measurement. Now, the one problem with that, King Edward was the king in the Anglo-Saxon Empire, which was England, Ireland, Scotland, and France and Germany. So those areas used his stuff, but other kings in other areas made the same declarations in similar times. So Switzerland had a different unit. Spain, Portugal had a different unit. So even though it's called standard measurement, the inch from one area to the next was very different. The foot was different, depending on what size the king was who made that declaration. So bigger than a foot. We talked about the cubit. We talked about the hand being smaller, but ones that we actually use bigger than a foot. What do we have? A yard is next. How many feet are in a yard? 3 feet. Now again, that had to be adjusted, and we use the yard for a lot of things now, but originally the yard had a very special purpose. The yard was the distance from your outstretched arm to either the center of your chest or the point of your nose. If you've ever gone to buy fabric, you'll see them, they grab it, they pull it out. That's 1 and 2. That's a yard. It was a tailor's unit for measuring fabric. That was always the width of a bolt of fabric was 1 yard, and then you measured out the lengths. So actually, when you're buying a yard of fabric, it's a square yard. But so again, King Edward declared his outstretched arm was the yard, and they adjusted them later to make them fit. Bigger than a yard, there are some units in there, like a fathom. A fathom was a navigational unit for boats. Well, no, actually it was, the fathom was used to measure whether a boat could navigate through a channel. 1 fathom was considered to be the shallowest water that most of the large vessels could actually navigate through. And a fathom is now adjusted to be about 6 feet. What a fathom was, how it was measured back then, was they literally took one of the taller sailors and threw him overboard. If he touched bottom and his head came out of the water, it was too shallow to navigate through. No, I'm hoping they pulled them back in later, but yeah, there were some disadvantages to being tall back then. There's units like a furlong. 1 furlong we consider to be 1/8 of a mile. That a furlong was actually the distance that most horses could run at full speed. About 1/8 of a mile is about where they could run before they get winded and have to rest. Yeah, then your faster horses, the quarter horse could run twice as far, about 1/4 mile is what they could run. One unit that's not as common that we're going to talk about is a rod. 1 rod is about 5.5 or 5.5 yards, or 16.5 or 16.5 feet. A rod was a shepherd's tool. The shepherd actually had 2 tools. They had a staff, which was that little hook, kind of like Little Bo Peep has. And that was used, you hook the animals around the neck so you could catch them to get up to them and shear their wool or attend to any medical needs or anything like that. The rod was a defensive weapon. It was literally a big stick. They'd take a sapling tree, cut it down, debranch it, and 16 feet, 16.5 feet, that's a pretty big stick. But you think about it this way, if they're fighting off like a wolf or something with nothing but a stick, you do want a little bit of distance between you and him. I mean, I'm probably hiding behind one of the sheep, take the little one, Where the rod ended up being used for measurement is, let's say Rob has some sheep and I have some sheep, and they go down in the same valley and they're grazing, and at the end of the day we want to take our sheep home with us. Well, Rob says he had 12 sheep and I say I had 15 sheep, but there's only 20 sheep down in the pasture. Well, one or both of us is lying. And of course, that turned into a small argument, and Rob ends up getting hurt. And, not a good thing. Sorry. But with cattle and horses, they solved this by branding. For sheep, branding had a couple of issues. One, well, the wool grew in so thick you couldn't see the brand anyway. You'd have to separate the wool to see it. And 2, wool is somewhat flammable.
You got burning sheep.
Yeah. Could be interesting.
Just kind of take a marker.
Well, now it's an ear tag.
Yeah.
But back then they didn't necessarily, ear tag technology, they had it, but it wasn't really accessible to the common person out in the middle of nowhere. So well, the thing is a lot of that would pollute the wool. So they had to be careful. So what they did, this was actually the beginning of land ownership. we'd find a landmark. Maybe it's a big rock somewhere, or maybe a large tree or whatever. And we'd say, okay, that's going to be our landmark. And I would take my rod and I'd lay it down on the ground and count 1. They'd take Rob's and lay his down. There's 2. Then I'd take mine and flip it. There's 3. And Rob's and 4. And we'd count, maybe 50 rods this way and 120 rods this way. That's where my sheep are going to pasture. Then we do the same over there so that we know we've got the same size pasture or whatever. And we'd block it off so the sheep can go, or we'd have to stay there and keep our sheep from crossing or whatever. And that was the beginning of really lotting off pastures. That was the beginning of the end of the open range. It used to be you marked your animals and let them loose and found them later. So to this day, by the way, if you actually look at an official survey of a piece of land, it is done in rods. It'll say from this, they have metal surveyor stakes for landmarks that are actually still there buried underground. And from this stake, from stake number 37984 or whatever, it is 18 rods north and 2 rods west is the corner of this property. Bigger than a rod was the furlong and some other things. We're going to jump up to the mile. Anybody remember how many feet are in a mile? 80, there we go. 5,280 actually, exactly. Just 80. You were close. Anybody remember how many yards are in a mile?
No.
Divide that by 3.
There you go. You can divide by 3. You get 1,760 yards in a mile. There's 220 or 320 rods. So blacking out now, but I think it's 320 rods. Bless you. A mile, there's actually a lot of different stories as to where the mile came from. Some people said the mile came from the distance King Edward could see from his out the window of his castle from where his throne sat. The most believable, most practical definition of where the mile came from is from Greek and Roman soldiers. Mil is the Greek prefix for 1,000. You talk about your property taxes. The mill rate is your dollars per thousand that you pay. A mile is the distance that the Greek and Roman soldiers could march in formation, marching 1,000 paces. So 1 pace was starting on your left foot, stepping to your right, and coming back to your left feet. So I think about that being about 5.28 feet, then 1,000 of them is 5,280 feet for a mile. So those are our standard units of length. If I want to convert between them, well, if I give you like 4 feet and I ask you to convert it into inches, many of you can do that without thinking too much. What is it going to be? 48, yes. We've done that conversion from feet to inches and inches to feet enough times in our life that feet to inches you multiply by 12 or whatever. But if we didn't know that, the way we would approach that would be like this. We would actually make the 4 feet into a fraction by putting it over 1. Now, I caught a couple looks there like, it's not a fraction. Why are we turning it into fractions? Well, because the actual conversion factor is the same way we did fractions. Remember when we had 3/4? We could change its name by multiplying the top and bottom by the same thing. We multiply by 5 over 5. 3 times 5 is 15. 4 times 5 is 20. 15/20 has exactly the same value as 3/4. It just looks different, has a different appearance. And the reason we were able to do that, we didn't change the value, we just changed the appearance, is because of this. 5 over 5 is called a unity fraction. And it equals 1 because the denominator and numerator have exactly the same value. Well, we're going to use a form of a unity fraction down here. We're getting rid of feet, so I'm going to put feet on bottom. We're converting to inches, so I'm going to put inches on top. And 1 foot equals 12 inches. Now you might be looking at this here saying, that's not a unity fraction. The numerator is not the same as the denominator. I didn't say that. Remember, I didn't say they were the same. I said they have the same value. 12 inches and 1 foot have the same value. So when I multiply by that, I can cross-cancel the feet. They disappear. 4 times 12 inches is 48 inches. 1 times 1 is 1. Well, 48 inches over 1 is just 48 inches. Now again, most of us have done conversions with feet and inches enough that we don't need to go through a process like that. But what if I give you something like 99 feet? Then I ask you, how many rods is that? That's a little bit of a different story. We haven't done that conversion of feet and rods very often. So I'm going to take my 99 feet and I'm going to put it over 1. In my unity fraction, what's going to go on? It's usually easiest to figure out what goes on bottom. So what's going to go on bottom of this fraction? Well, it's going to be feet because I'm getting rid of feet, right? So put in the units first. And what am I changing it into? Rods, right? So if I put my units in there first, it usually makes it easier for us. Now I need to go to my equivalencies, and that's what these are over here. Those are equivalencies that relate one unit to another. And I need to find one that relates rods to feet. And you've been saying it there, Rob. What is it? Yeah, 1 rod is 16.5 feet. So 1 rod is 16.5 feet. That is a unity fraction. 1 rod is equivalent to 16.5 feet. The numerator and denominator have exactly the same value. So now again, I can cross-cancel the feet. The units, the feet, are gone. Just like canceling out variables. That's one of the reasons why we did the variables within our fractions, is that process right there. Now we have 99 times 1 rod. That's 99 rods. We've got 1 times 16.5 is 16.5. And we simply divide that out. 99 divided by 16.5 is 6 rods. So 99 feet is 6 rods. Not so bad? It gets worse? Well, not yet. Give me time. Okay, so our next step. Let's look at some of our other units in the standard system. We'll talk about the metric system all at once because the metric system kind of fits together. Before we talk about some of our other units, there are some gray areas we need to talk about. The first one I'm going to address is the difference between volume and capacity. Most people equate the two. And really, the difference between them is very, very subtle and almost unimportant. But volume is measured in lengths. So it's measured in length units. If I wanted to find the volume of a box, this might be 12 inches by 10 inches by 6 inches. I would have to use those lengths and calculate the volume. This would actually be 720 cubic inches in volume. So volume is calculated from length measurements. Capacity involves standard size containers. We're going to come back and talk a little bit more about, well, let's do volumes right now. Why not? In volumes, to get to volumes, you first must really talk about areas. And a lot of people get confused when they see like 7 square feet being converted into square inches. Because they think you got to square the 7 to get 49 or something. You don't. That squared foot is a unit. The squared is a label, not a power, not an exponent. It's like having an x squared. The x squared doesn't mean you do anything to the number. It just means the value of x is multiplied in there twice. 1 square foot is 1 foot by 1 foot. And yes, 1 foot is 12 inches, so it's 12 inches by 12 inches. So that is 12 by 12, or 144 square inches. So 1 square foot is 144 square inches. So it is a different conversion factor for areas. For volumes, one cubic foot is 1 foot by 1 foot by 1 foot. That's 1 cubic foot. But that would be 12 inches by 12 inches by 12 inches. Well, 12 times 12 times 12 is 1,728 cubic inches. So 1 cubic foot is 1,728 cubic inches. So for volume, the conversion's not 12 anymore, it's 12 cubed. And that's the way it is for all of our units as we convert them over. We will talk more about areas and volumes when we start calculating area and volumes and their conversions. So let's get back to capacity, those standard size containers. I'm going to start with a gallon. A gallon was the size of a standard men's hat. Now, I'm not talking about a cowboy hat.
Is that the 10 gallon?
Well, exactly. The 10-gallon hat, and I'll talk about that phrase in a second. I'm talking about your standard dress, like the little derby hats that they wore for standard. And if you look at it, those hold about a gallon. Now, you brought up the phrase a 10-gallon hat. Not mathematically accurate. It's just a figure of speech. That was just their way of saying a cowboy hat was bigger than a standard hat. So that was kind of their sarcastic thing. Well, that's a 10-gallon hat. It's a big hat is all it meant. Obviously, it doesn't hold 10 gallons.
Because that would be a big.
That would be a really big. I mean, a 5-gallon bucket would be huge on your head. But think of 10 gallons up there. That would be big, yes. Smaller than a gallon. What's our next smallest unit? Anybody tell me?
Pint.
Quart. How many quarts are in a gallon? 4. The word quart actually is short for the word quarter, which implies 1/4 of a gallon. And that's what a quarter was really brought out, was as 1/4 of a gallon is what it actually was defined to be. That's where it came from. Now, smaller than a quart is a pint. A pint was, and how many pints are in a quart? 2. Now, this is one of those measurements that was adjusted over time. A pint was, it does not originally take 2 pints to equal a quart. They adjusted their size. A pint was a standard size glass or jar that was used for all sorts of things, and serving beer and ale was one of them. So that was where that came from. Then smaller than a pint, we have a half pint, which is now called a cup. They actually did have a unit called a half pint at one time. There are, of course, 2 cups in a pint. The half pint and the cup were so turned out when they went to adjust things. They turned out to be so close in size, they just eliminated the half pint, and they go with cups. Now, the cup and the pint were adjusted to make 2 cups in a pint. The cup actually did originally come from your cupped hand. It was a dry, there's a mixture here between wet and dry measurement. The gallon and the quart were wet measurements. The cup was a dry measurement. You would dump powder like flour or sugar in your hand, and what stayed in your cupped hand was a cup. And when you put it in a mix, I actually have a friend of mine who's a caterer, and when she does stuff, she still measures her flour and stuff in her hand. And I've checked her, and it's like dead on. I mean, it's... So, a little bit of a side note here, by the way. The abbreviation for quart is QT, and pint is PT. And in some type fonts, a Q and a P are mirror images of each other. I did this intentionally without the little curve on the back of the Q there. If you have any dyslexic tendencies at all, it is very easy to switch those two if you just take a quick glance. So make sure you read those abbreviations very carefully. Smaller than a cup. We have tablespoons. Actually, before we get to that, I'm going to do another one. Smaller than a cup, we're going to put in fluid ounces first. Anybody remember how many fluid ounces are in a cup? 8. A fluid ounce is defined to be the volume of 1 ounce of water. That's been adjusted through the years as well, so that 1 cup doesn't necessarily weigh 8 ounces. 1 cup of water doesn't necessarily weigh 8 ounces, but it's really close. Smaller than a fluid ounce. Then we will go to the tablespoon. Now, most people know how many tablespoons are in a cup rather than how many tablespoons are in a fluid ounce. Does anybody know either one? There are 16 tablespoons in a cup. So divided by 8 would be 2 tablespoons in a fluid ounce. So there's 2 tablespoons in 1 fluid ounce, 16 tablespoons in 1 cup. Smaller than a tablespoon, we have teaspoon. Anybody know how many teaspoons are in a tablespoon? There are 3. There's 3. Now here's another spot for a side note. Abbreviations for tablespoon and teaspoon. Teaspoon is either a small TSP or a small t. Tablespoon could be TBSP or a capital TSP or just a capital T. Now you can see I exaggerate. I use a capital T and a BSP to make sure I exaggerate it. But it is really easy to confuse these in recipes when you see a TSP or just a T. You have to look to see whether it's a capital letter or a small letter. Trust me, when you make cookies and it says 3 teaspoons or 2 teaspoons of salt, if you put in 2 tablespoons of salt, even for a fat guy like me, those cookies are unedible. Trust me. Now the next couple things I'm going to put up here you don't have to write down. I'm just going to throw them up here to show you that they actually are real units. Smaller than a teaspoon. We have 2 dashes. A dash actually is from a spice shaker. Now, I'm not talking about a salt or pepper shaker. I'm talking about a spice shaker. A spice shaker was much larger, had larger holes in it, and I believe it had a standard set of holes, too. I think it was, I'm trying to remember if it was 9 or if it was 11 holes in a standard spice shaker. It was a standard hole pattern he had in it. And he just took that shaker of spice, and 1 dash was just 1 quick tilt, and what came out was a dash. Smaller than a dash is a pinch. Anybody know how many pinches are in a dash? 3. Close. Smaller than a pinch? Smidgen. There are 2 smidgens in a pinch. Now, a pinch is exactly what it sounds like. You stick your fingers in the powder That was a powder again, same with dashes were powdered. Tablespoons and teaspoons were originally fluid. Because a tablespoon, you actually had to let the fluid bead up on your standard size tablespoon to make it work. Now, what they used for tablespoons back then were much larger than what we use now. Just, what our standard eating utensil is much smaller than what they used at that time. But anyway, the pinch, you actually reached into the powder, pinched your fingers together, and what was between your fingers was a pinch. A smidgen, this one seems kind of nasty to me. You stuck your finger in the powder, and what stuck to your finger was a smidgen. Now, so the cook with sweaty fingers had big smidgens, apparently. But that was always kind of set wrong with me. There are other units of capacity larger than a gallon. 1 peck. Anybody know what 1 peck is? 2 gallons. You ever hear the Peter Piper picked a peck of pickled peppers? Where you see a peck mostly anymore, most produce was measured in pecks, bought and sold in pecks. If you go to a strawberry patch, they'll have the 1 peck and 2 peck crates of strawberries. That's what you'll buy it in. No, you don't have to have that. 1 bushel was 8 gallons or 4 pecks. Anybody know what a barrel is? Well, most people say 55, but 55 gallons is a drum. A barrel is 31.5 gallons. And yes, a barrel was actually a wooden. Okay, so those are our sizes. Now again, just like all of our lengths, they're called standard units, but they were not standard from one country to another. They were unfortunately very different. Well, next we need to make another distinction between weight and mass. When we do measurement, we commonly grade the area between these two, but there's some very important distinctions between them. Weight is a measurement of force. It uses the units of force. And weight itself is a measurement of the force of gravity on an object. Mass is a measurement of the amount of matter, the amount of material, atoms and stuff in an object. Now, obviously, there's a relationship here. The more matter an object has in it, the more it's going to weigh, the more force gravity is going to have on it. So an object that has more mass does weigh more. How they are measured. Weight is usually measured against a spring. So you take a spring, you hang it on something, like that. That's in its relaxed state. Then at the bottom of that spring, you hang whatever it is you're going to measure. And once you hang that object on there, the spring stretches out. Like that. The amount the spring stretches is the measurement of the weight. Well, how do you measure how much the spring stretches? Well, they had some sort of a plate on there, and it was marked out with numbers on it, right? There's an indicator on there on the spring itself, and when it stretched, that indicator would move. That equally spaced set of numbers is called a scale. That's why the device used to measure weight became to be known as a scale. It was just a spring with a scaled set of numbers on it. Mass is measured with a balance. So a balance basically looks like a teeter-totter. We put our object that we're trying to measure on one side, then on the other side we put known masses until it balances. And once it balances, whatever mass we have over here, the known masses, that equals the mass of the object we're measuring. You might look at that and think, well, both of them involve gravity to measure. And that is true. But if we go to the moon, where gravity is about 1/6 of what it is on the Earth, this spring here is going to stretch only about 1/6. So the weight of that object is going to change because gravity changed. Over here on the balance, the gravity is going to pull less on our object, but it's going to pull less on the known mass too. So it's going to have the same mass. So mass is constant regardless of the gravity you're in. Where weight depends on the gravity you're in. Now on Earth, gravity is relatively constant. If a 200-pound person went from the equator to the North Pole, the equator is where gravity is the least, and the North Pole is where gravity is the most. A 200-pound person could change by as much as 4 to 6 pounds, depending on their exact location and altitude. So that's not very much. That's just a couple percent. So because gravity is relatively constant on Earth, we tend to kind of jump back and forth between weight and mass without really thinking about it. But there is a difference. I wanted to point that out. Now in the standard system, we tend to focus on weight, and mass is kind of a secondary object. There is a unit of mass in the standard system. The unit of mass in the standard system is called a slug. Any of you ever heard of a slug before? Yeah, not as a unit of measure, at least, right?
Right.
The phrase, you had a whole slug of those, that's where that comes from. It's a unit of mass. A slug is about 32 pounds. We tend to focus on weight. Now, I've already mentioned pounds, but let's go up to our largest unit of weight. The large unit of weight we tend to use is a ton. 1 ton is known to be 2,000 pounds. That is actually what is called 1 net or short ton, which implies that there's something called a gross or long ton. For this class, by the way, whenever you see the word ton, it implies 2,000 pounds. A gross ton or a long ton was 2,240 pounds. The difference was just like your paycheck. If you work 40 hours in a week at $10 an hour, you've earned $400. But you don't get $400, do you? You might get like $290 because they take out taxes, whatever. The $400 is your gross pay. Your net pay is the $290 or whatever you actually get to take home. Same thing here. A ton was originally used for measuring, buying and selling grain. Well, you go to stack a ton on a scale, it doesn't stay on the scale. It falls off the edges. You have to have it in a container. So the container that held a ton of grain was about 240 pounds. So the gross ton was the grain with the container. The net ton was the actual amount of grain that you got. So then we have the pounds. Let's go from the pounds there. What's the abbreviation for pounds, by the way?
LBS.
LB or LBS. We typically don't put the plural, the S on it. We just use the LB. But the reason for it would make a lot more sense to use PD for pounds. But in the bookkeeping system for buying and selling grain, PD was already used for paid. So they went to the the Latin word for pound is libra, so that's where LB came from. One of the funny things about the English language is if enough people mess something up enough times over a period of time, it becomes acceptable. PD has now become an acceptable abbreviation for pound. It's still confusing though, so they try to stick to LB. Kind of like the word potato. Anybody know how to spell potato?
Apparently none of us do.
Well, if I said Potato, would you say that was right?
Yeah.
Most people would. It's actually incorrect. It's Potatoe is the correct spelling of potato. There's an E on the end. But enough people messed that up, they forgot the E, that in the 1960s, they let, just with the TO instead of the OE, they accepted that as an acceptable alternative spelling. Yeah, but when you make it a plural, it's TOES. You have to add an E on it. That's because it technically has an E on it without the plural. Yeah, there was actually a big fuss in like 1989. Vice President Dan Quayle messed up, but the student said Potato, and when Dan Quayle was in school, that was not an acceptable spelling. That would have been incorrect. So the media made a big stink that the vice president doesn't even know how to spell potato.
Right.
Well, he did. It's just since he had left school, they had changed it and made it an acceptable alternative spelling. So I got off on a little bit of a tangent there. Smaller than a pound, we have ounces. Anybody know how many ounces are in a pound? 16. Very good. The abbreviation for an ounce is OZ. That is also from the Latin word for ounce, which I cannot remember right now, and it really doesn't matter. Smaller than an ounce, we have drams. Grams are metric. Drams are standard units. A dram, there are 16 drams in an ounce. A dram is an apothecary unit. It was used for measuring out medications. You might be prescribed a quarter of a dram of a medication or whatever. Even smaller than a dram, there are grains. There's 7,000 grains in 1 pound. That was also used for measuring out medications, and for any of you that are into shooting and hunting, that's your gunpowder and stuff for your shells. There are other units in there like stones and hundredweights and stuff like that that really aren't horribly important. Now, another little side note. Remember we said that from one country to the next, different leaders standardize these units at different times? In weight is where it really had the hugest effect. You hear on the news all the time, the price of gold's up to $1,800 an ounce or whatever. Well, the ounces and pounds that are used for precious metals are not these ounces and pounds. The traditional center for buying and selling precious metals, of course, this all was established in Europe before this country was even colonized, but the traditional center was the island of Troy in the Mediterranean Sea. So we use Troy measurement. And in the Troy measuring system, 1 Troy pound is only about 0.82 to 0.83 regular pounds. But 1 Troy pound only contains 12 Troy ounces. So a Troy pound is smaller than our standard pound, but a Troy ounce is actually slightly larger than our standard ounce. So if you bought an ounce of gold, it actually is slightly more than an ounce because you're buying a Troy ounce of gold. The only reason I point that out is because you hear that a lot in the news. Precious metals, depending on the economy, fade in and out of popularity. You hear a lot of advertisements. They've faded now, but a year ago you were hearing a lot of advertisements about investing in precious metals and stuff like that. The other thing is there's one big scam out there where the hey, the price of gold is $1,700 an ounce. We'll sell you, ounces of gold. Well, they send you regular ounces instead of troy ounces, and they're scamming. They're shaving 6-7% off the top of that because of that. Okay, so that is our standard units. The standard units are what we would call an evolved measurement system. Evolved makes it sound really fancy and complex, and it kind of isn't. As we saw from the origins of these measurements, it came from need and different measures. Some people started using their thumb, some people started using their foot, some people use whatever. And they forced them together later. They adjusted them to fit to make them work. That's why it's 12 inches in a foot and 3 feet in a yard and all that. And 16 ounces in a pound and 2,000 pounds in a ton. Everything's been adjusted to make it fit. They were never intended to work together. They all developed separately and slowly were put together, forced together to make a measuring system. Nobody actually sat down and thought about how could we make this work, how could we come up with a system to make it work well. So when they developed the metric system, that's what they did. They had been using the standard system for thousands of years. They knew what worked well and what didn't in the standard system. So the metric system was actually developed in the late 1800s. And it is a planned system. They actually sat down about it and said, okay, what parts of the standard system really work well and that we should use? And what parts about it are really difficult and confusing that we should find some way to fix? For example, if I go back up to my capacity here, the relationship between capacity and volume, they're basically measuring the same thing. It's two different ways of measuring the same thing. But if I want to equate a gallon into cubic inches, 1 gallon, I shouldn't even put equals, I should put a wavy equal sign. It's approximately equal to 231 cubic inches. A very ugly conversion. 1 cubic foot contains about 7.48 gallons. Again, kind of ugly. A lot of people round that off to 7.5 to make it a little bit neater. I should again put approximately, not equals. But things like that just don't work really well or nicely. They thought about when they developed the metric system, said, okay, how can we make this easier? Well, so they started out saying we are only going to have one unit of measure for each thing. For length, they use the meter. Now, obviously, there are things that a meter, I used to have one, I think I still have one behind me. I do. A meter is this thing right here. Looks really close to a yard. A yard is 36 inches. A meter is actually 39.29 inches. Would have been really nice if they'd have made a meter equal a yard, wouldn't it? Well, they did. But remember I said a yard was not a yard from one country to the next. They made the meter equal the Swiss yard. The metric system was developed in Switzerland. So the meter is equal to the Swiss yard. So if they wanted to measure something smaller than that, they came up with prefixes. Yeah. Centi, milli, deca, deci. And we'll go over those prefixes in a little bit. The unit they use now, remember we said we tend to focus on weight in the standard system? We had that slug for mass, but very seldom see it used anymore. In the metric system, they tend to focus on mass. The unit of mass was the gram. for weight. Remember, weight is a unit of force. So for weight and force, they use a unit called a Newton. That's probably going to be one of the last times you hear the word Newton, because it's really only used in scientific and engineering applications. And then for capacity, they use the unit of a liter. Now, as I said, they started out with that meter equaling a Swiss yard. And that was the only link between the metric system and standard system that exists. Everything else was built off of that meter. 1 liter, in order to make the conversions easy, was defined to be 1 centimeter cubed is equal to 1 milliliter. We'll go over what a milli and a centi are in a little bit. But they actually defined the units for capacity off of the length unit. So there is a very simple conversion from, if you use the lengths to calculate a volume, you can very quickly and simply convert it to a capacity. 1 gram is then the mass of 1 milliliter of water. So there's a very simple link between their measurements of mass and their measurements of capacity and length. So let's look at those prefixes. At the center of our chart is going to be our standard units. So a meter or a gram or a liter are going to be our main units at the center here. A little bit of a side note, you can see I used a capital L to abbreviate liter, because when I learned the metric system, which was in the late 1980s, typewriters, the small l and the number 1 were almost indistinguishable. In fact, some of the very old typewriters, before my time, the mechanical ones didn't even have a 1 key on them. You used a small l for a 1. So to avoid confusion, if you had something like this, is that 51 or is it 5 liters? Well, if you made it a capital L, it's very obvious that that's 5 liters. That's why when I do pounds, by the way, if I have like 7 pounds, you'll see me underline it so that you know that's an L. It's part of the abbreviation, not a 1. Now, yeah. Now, with our modern computer fonts, type fonts, and many of them, a 1 and a small l are distinguishable. They're different. So it has become acceptable to use a small l to abbreviate liters. You'll see me using a capital L almost all the time because my 1s and my small l's look the same. But it is acceptable to use a small l. So now if we wanted to measure something smaller than our standard unit, the first abbreviation is deci. Deci meant 1/10. So like for a decimeter, that's just dm was the abbreviation. dg for decigram, dl for deciliter. Smaller than deci is centi. Cent, of course, from century or cents in a dollar, is 100th. So a centimeter was abbreviated cm. Next was milli. We said mil, the Greek prefix mil stands for 1,000, so milli is 1,000th. So a millimeter is abbreviated mm. That's 1,000th of a meter. Now at that point they stopped going every power of 10. You know, they went 10, 100, thousandth. They didn't go a 10,000th and 100,000th. They jumped. They skipped those. They went up to a millionth. A millionth is micro. Now the abbreviation for micro is the Greek letter mu, because little m's are already used for milli. So mu m is a micrometer. Now if you're in a medical field, the medical field was one of the first fields to have to keyboard all their information into a computer. There is no mu key on a keyboard. And even now, you would have to go through a menu to select that symbol. So in the medical fields, they use MC for micro. So MCM would be micrometer. MCG would be microgram. They do keep going smaller yet. The next one would be a billionth, which would be nano. I'm not going to put it down there because we're not going to convert down to nano. But you used to hear a lot of fuss about nanotechnology. That's what it was. I realize I'm like a minute over already, but I'm just going to finish off these prefixes and then we'll call it. Larger was deca. Since DM was used for deci, a decameter is DAM. Damn. That's 10 meters. Hecto was 100. That's HM. Kilo is 1,000. That's KM. And then again, they skipped. They didn't do 10,000 and 100,000. They skipped up to 1,000,000, which is mega. It was abbreviated with a capital M. So capital M, little m is a megameter, is 1,000,000 meters. Not used very much because the distance around the Earth at the equator is only like 25,000 kilograms or kilometers. So it would only be 25 megameters around the whole Earth. What is more often used is a megagram. 1 megagram is 1,000,000 grams or 1,000 kilograms. That is defined to be 1 metric ton. Okay, I've gone a few minutes over. There will be a new homework due for Monday. And if you look on my math lab, there is an optional quiz out there, quiz 12, that you can do tonight if you want to, by 11:59 p.m. What's that? Well, yeah, so if you do that quiz, what I'll do, like I said, with these optional quizzes is I'll use it to replace your lowest other score quiz. Okay, sorry I went a couple minutes over, but you guys have a great weekend, and we'll see you on Monday.